So we're going to work really hard on this unit because this is the unit that correlates into our 30-1 unit. And the 30-1 unit has 3 units on trigonometry, actually. 3 chapters, not 3 units, 3 chapters. So we're going to work really hard so that our 30-1 unit is easy, not hard. Okay? This mainly covers almost chapter 4, all of chapter 4 without radians. I think I might add a little bit of radians in for you guys, not test you on it, but show it to you so that you're more prepared for next year. It's just a difference in degrees to radians. So that when you take chapter 4 next year, you're like, it's easy, I've done this. Okay? Yeah. So, we have Cartesian plane. So the label quadrant 1, 2, 3, and 4. So we've labeled these before, we're going to label them again. Make sure your phones are away or you're really not learning this. So, this is quadrant 1. And then we go counterclockwise. This is quadrant 2. This is quadrant 3. And this is quadrant 4. We go counterclockwise. No. Well, sometimes they use Roman numerals, so I like you just to know what they are and not be completely lost when they give them to you. Okay, guys, quiet. So, we are going to draw stuff on this Cartesian plane. We're going to draw angles. Now, we know that a full rotation is 360 degrees. We know that, correct? We just need to know how to place it on a Cartesian plane. Okay? So we're going to label the axes first. And if you see here, we're going 1, 2, 3, 4, correct? We're going counterclockwise. We agree? So we're going to start in quadrant 1. This is always going to be 0 degrees here. You have to put the degree symbol. People will try and get away with it in grade 11. Your problem with it is that grade 12, there's degrees and radians. And if you don't put the degree symbol, it's a radian. So it's totally wrong. All right? So we have to make sure we have our degree symbols and not drop them off. Now, we know that a box makes a what angle? A 90. So this is 0. This is going to be 90 degrees. So when we do positive degrees, we always go counterclockwise. Start at that 0, we go counterclockwise. So this is 90. What's this going to be? 180 degrees. And we make sure we have the degree symbol. This is going to be 270 degrees. And then comma, this is going to be 360 degrees. And then we could actually keep going. Add 90, so we would get 450, and then we'd add 90, and add 90, and we could keep going. That would just get infinite angles that are positive. Okay? What we're going to learn as well next year is we can do negatives. And I might show you a bit this year too. So if this is 0, this would be negative 90, negative 180, negative 270. It just literally goes clockwise. That's it. Counterclockwise is positive angles, clockwise is negative angles. That's it. Nothing crazy. All right. So here it says, in geometry, an angle is formed by 2 rays with a common endpoint. Okay? So the rays meet where the angle is. The starting position is called the initial arm, and the final position is called the terminal arm of an angle. If the angle rotates in counterclockwise, then the angle is positive. We said that. And then clockwise, it is negative. So this is our initial. Our initial arm will always start at 0 degrees, just so you know. And then our terminal arm will end wherever the angle is. And the reason why we have to have this arrow in the middle, do you see there's a little line with an arrow? Is because you have to tell which direction you're going. So if I start here and I go this way, that's counterclockwise. So this is a positive angle, correct? What you're going to learn next year is if I actually went this way, I'm going clockwise, this would be a negative angle. That's it. So that's why this arm is so important to draw, because that's showing you that it's a positive angle. And you're like, well, it's always going to be this way this year. Yes, but next year it won't be. So we have to learn proper etiquette of math for this year and next year. So, angles in standard position. This is important because they're going to talk about it next year as well. Angles in standard position. The diagram in group A shows the angles in standard position. The angles in group B are not in standard position. What are the characteristics of an angle in standard position? Yeah. Yeah, your vertex is on 0, 0. So if you look here, vertex 0, 0, it's always rotating around the center. So where your terminal and your initial arm and your terminal arm meet, it's on 0, 0. What else? What can you tell me about the initial arm? I already told you about this, yeah.
The initial arm is at 0 degrees.
Yes. So the initial arm starts on the x-axis at 0 degrees. This one is on the vertex is at 0, 0. This one, I don't know what this is. This is just chaos. This one, it starts at 0, 0, but if you look at my terminal arm, or my initial arm, is it on the x-axis? No, and this one's just chaos again. This one has an initial arm on 0 degrees as well, and it's rotating about 0, 0, right? So your initial arm, all right here, is at 0 degree start, or the positive x-axis. So those are the key things about standard position. A standard position angle rotates around 0, 0 and starts on the x-axis. Do you agree? Okay, that's the key things about standard position angle. Starts at the positive x-axis at 0 degrees, rotates around 0, 0. Okay? And as you can see, these ones do not. Okay. This one says, which diagram shows an angle of 70 degrees in standard position? Which one of these? B, even if you know nothing about 70 degrees, you know standard position, and standard position has to start on the x-axis and rotate around 0, 0. This one starts on the x-axis and rotates around 0, 0. Now, why is this 70? Because this is 0 degrees, this is 90 degrees, 70 is a little bit less than 90. Correct? And if I look here, I also have to have an arrow pointing to my final arm. So I always have an arrow from my initial to my final. If my initial to my final is in counterclockwise fashion, it is a positive angle. We agree? So the arrow has to be drawn correctly. Do you see there's an arrow? It has to be drawn. And the reason why is, I'll show you this. If I went this way, which we're doing a lot of this next year, if I actually had the arm this way, this would be 0, this would be negative 90, this would be negative 180, this would be negative 270, this would be negative 360. What would this negative angle be? Anyone have any idea? If I went this way? It's more than 270. How many more than 270? 20 more. So it would be negative 290. So there are two angles there. Do you see that? That would end on that same arm. There are two angles that would end on that same arm. So if you don't draw the arrow from the initial to the final counterclockwise, then I don't know if you're drawing 70 or if you're drawing negative 290, or all the varying levels of it, because I can keep rotating a whole bunch of times to get different angles. So do you see how important that arrow is? It's very important. Okay. We're going to sketch the rotational angles in standard position and state which quadrant the angle terminates. Before you start, you will always label the axes. Axes. It's an axis. But anyways, you will label them every single time because that will help you. Also, if you don't label them, I don't know what angle you're drawing. Okay? I don't even know if you know what angle you're drawing. So I'm going to go around. I'm not going to be lazy. I'm going to do this every single time. I'm going to go 0 degrees. I'm going to go 90 degrees. I'm going to go 180 degrees, 270 degrees, 360. Every single time. We agree? I'm drawing in standard position. I will always draw in standard position, just so you know. For 11, grade 12, it will always be in standard position. So what I'm going to do, I'm going to bold 0, 0, because that's my rotating dot. I'm going to bold 0, 0, because that's my rotating dot. And I'm going to draw an initial arm on the x-axis every single time. And you're like, when won't I? You never will not. You will always start at 0, 0. Every single time. Grade 11, grade 12. Always. Okay? We're always drawing in standard position. Especially in grade 12, we're starting in standard position because it's a positive angle. Okay, now I need 120. What do I know about 90 if I split it in half? What is 90 split in half by? 45. So if I needed a 45-degree angle, I could just go straight up the center. Doom, right? Same amount this way, same amount this way. Do you agree? Don't draw this. I'm just proving a point. So if I needed 45 degrees here, I could just go straight up the middle, guesstimate it, and I'd have 45. We agree? If I need less than 45, I'll angle a little more this way. More than 45, I'll angle a little more this way. Right? But 45 cuts us down the middle. We agree? All right. How much more do I need than 90? 30. So am I going to go right to that 45? Am I going to go really close to the y-axis? No, that's like 1 degree, 2 degree, 3 degrees, right? So if 45 was right up the middle, 30 is a little less than that. Oh, I kind of went right up the middle. Maybe something like that. Now, am I going to pull out a protractor and be like, girl, that's not 30? No, not if it's relatively close to 30. If you draw it way down here close to 180 and then say that's 120, I'd be like, no, it's not, right? But if you're at like 33 degrees or 35, we're good. Okay? Could you bring a protractor in? Sure. You would just have to put it on here and go 30 degrees and sketch it out. You can bring protractors into your diploma. They're allowed. Okay. What am I missing? I need an arrow. Because if not, I could actually be a negative angle, couldn't I? Absolutely could be. I could go from the bottom all the way to that terminal arm, or from the top all the way to the terminal arm. I have 2 angles I could draw right now. So I need the arrow. So I start here with a straight line, and then I, boom, arrow to this one. And then what I should write in here is 120 degrees, so I know that this is the 120 degree angle. I'm gonna sneeze. I want you guys to try the other 2. Make sure you're labeling 0, 90, 180, 270, 360. Okay, so this would be 0, 90, 180. And I always tell people to label, and there's always 5 or 6 lazy people who do not label. Don't be those 5 or 6 lazy people. Make there be no lazy people in this class, please. Because every time I walk around, I will see people not doing it on their... They'll do it now, and then they'll get to their notes, they will not do it. You have to label it. Because if you don't label it, it could be a positive angle, it could be a negative angle, right? I can label those 0, 90, 180, 270, 360. I could label them 0, negative 90, negative 180. You need to label your axis. It will help you. Trust me. Okay? 270, 360. So I need 309. So I can either go, okay, 309 minus 270 and find out how much more it is than 270, or I can go 360 minus 309 and see how much less it is than 360. Either way, it should get me the same thing, right? I do know I'm rotating about 0, 0. I do know I have an initial arm on here, which you should have. 309 is how much more than 270? It's 39. So that's almost close to half, right? So I'm a little shy than the middle. So I'm going to go here, let's say. Then I have to take my initial arrow to final and put 309 degrees. Right? I swear you can talk about it in the next break. You can talk about it in the next break. I'm not talking break in class. I mean break in working on a question. You're fine. Okay. We need 17 degrees. 17 degrees is just a tiny bit more, correct? But I'm still going to label. 0, 90, 180, 270, 360. So I'm going to be here and a little bit higher. Arrow up, and I put 17 degrees. Okay? Next, we're going to talk about reference angles, which are extremely important in grade 12. If you can't find reference angles, grade 12 trig is something awful. It's not going to get flipped over, so you don't want to look at it. Okay. Angle in standard position. An angle is said to be an angle in standard position if its vertex is in the origin of the coordinates and the initial arm coincides with the positive x-axis. We've talked about this. Okay? We talked about 0 to 90, 90 to 180, 180 to 270, 270 to 360, where they're found. Talked about that. Now we're going to talk about reference angles. Okay? I have to get you guys to know what a reference angle is. It's very, very, very important. And I think it's easy. Some people struggle. We're going to go through and we're going to make sure we know how to do it. Okay? So a reference angle is a cute little angle. It's acute. It's less than 90. Remember your teacher when they taught you acute, they'd be like, it's a cute little angle. And then obtuse didn't have anything, but it just was bigger. Okay? So it's obtuse, yes. So acute is a little angle. It's a cute little angle. It's between 0 and 90. Everyone gets that. Everyone's really good with that. The key thing about the reference angle is it is the angle between the x-axis and the terminating arm. The x-axis and the terminating arm. So I always call them the bow tie angles. That's how I help myself out. So when I draw it, I go like this. Okay, if my terminating arm's here, it's this angle. 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 Which actually, if you draw it as triangles, makes a bow tie. Okay? It's not an hourglass. Some people will try and tell me the reference angles between the terminating arm and the y-axis. That would make an hourglass, right? Like this. It is not that way. It is x-axis to terminating arm. So it's the small angle from the x-axis to the terminating arm. X-axis to terminating arm. X-axis to terminating arm. Okay? So here's a little description. So I'm going to write here, x-axis is a little sum to terminating arm. If you never go from the y, you will be golden. So, if it's in quadrant 1, the reference angle equals the actual angle, right? Because this is the bow tie angle. I am my own reference angle. So quadrant 1, if I ask you for the reference angle, boom, it's the angle. You're done. That's the easiest one. You should throw a little party. Super fast. Easy. Right? Quadrant 2. Your angle is here. This is good. That's your angle. However, your reference angle is the bow tie angle. So it's the angle from the x-axis to that. Right? Your reference angle is this angle here. From here to here. So if it's 120, I know if I label my axis, this is easier. It takes me 180 to get to here, correct? From here to here, we know this because that's what a little protractor is, 180, correct? So if I need this little angle, how did I find it? How did I find this angle? Given 120.
180 minus 120.
Yeah, so when you're in quadrant 2, your angle, your theta, which looks like a little cowboy, your theta, got all thick. Your theta, which is just the angle. Your theta is 180 degrees minus, oh sorry, your reference theta is 180 degrees minus the angle. Every single time. So in quadrant 1, your reference angle, boom, is the angle, right? In quadrant 2, your reference angle is 180 minus the angle, because that'll give you the little angle between the two, correct? Quadrant 3. So this is 240. How do I get my reference theta? How do I get to this is 260? Or sorry, 240. How do I get to this is 60? What do I do every single time? I need this little angle to here. So what can I just take off of 240? This whole circle. If I take this half circle part off of it, which is how many degrees? 180, I'll be given what's left here. Right? So in quadrant 3, your reference angle is always the angle minus 180 degrees, isn't it? So if I went 240 minus 180, I have 60, which is what's left there. You see that? The reference angle for quadrant 1 is the angle. For quadrant 2, it's just 180 minus the angle. For quadrant 3, you do the whole angle and you subtract off that semicircle, 180. It's best not to memorize. It's best to understand why you're doing these. Because if you're memorizing, you can oopsie, right? I don't like memorizing. I like understanding. Memorizing, you oopsie. Understand, you can't oopsie because you understand it. Let's look at quadrant 4. Oh my gosh. So it's 45. The whole thing is 315. This is 45. What am I doing? I'm making a whole circle, aren't I? So for quadrant 4, my reference at theta, what did I do to get that 45? Yes? 360 minus the angle. If I take 360 and I take off the angle, it's what's left over, right? We're just trying to finish we're trying to make a whole pizza here. So we're going to do 360 minus the angle. So I'm not joking. Math is easy if you understand it. Math is hard if you memorize. If you memorize, you can screw up because you might mess up your memorizing. If you understand how to find it, you can't make a oopsie because you just understand it. You do it every single time. You're not going to go, oh, is it 180 minus or is it the angle minus 180? I can't remember. That scares me. Memorizing scares me. Understanding does not. Okay? So let's go through. Let's go back how we did it. So the reference angle is from the x-axis to the terminating arm. So if I calculate that, my reference angle is my angle because it's just what it is in quadrant 1. In quadrant 2, it takes me 180 to get to this. Well, I want to find out what's left over. So I would do 180, which is the whole thing, and I'd subtract off the angle, and I would know what was left over from in quadrant 2. In quadrant 3, I'm too much. I have too much of an angle. So this whole thing here is 240. If I take the 180 out of the whole thing, that takes out all this top part, I'm left with just the reference angle, which is 60. So that's why I do the angle minus 180. And this last one, I'm trying to form a whole pizza. I'm trying to form a whole circle. So I do 360, I take this little piece of pizza out. Right? I take this big piece, and I'm left with this little piece here, which is 45. Okay? Next page. So here it goes through and it sums it up. Theta equals reference angle. Okay? We did it on the previous page, so it doesn't matter. Okay. We're going to draw the reference angle for the degree measures listed below. So first off, we're going to draw the degrees. So go through, and I want you to draw the degrees of all these. What am I expecting you to do first for every single one of these, though? Label 0, 90, 180, 270, 360. Every single time. 0, 90, 180, 270. We need to get good habits so that when we open it up past 360 or less than 0 next year, we can do it. We're not overwhelmed because we're so good at this. We understand it. We don't memorize. So label, label, label. Plot the angles first. So go through and plot all the angles first, like we just did. Then go back and try and get the reference angles. Okay, first thing I'm going to do, I'm going to go 0. I'm going to go 90. I'm going to go 180. I'm going to go 270. I'm going to go 360. Then I need 243. So the easiest way, because I drew those numbers, it sets me up for at least what quadrant my arm should end in, correct? What quadrant should my arm terminate in? 3. 1, 2, 3, 4, right? We're going to keep asking questions like that so you know your quadrants. So 1, 2, 3. It's going to terminate in 3. So I can either say how much less is it than 270 or how much more is it than 180. Either way, whatever way works for you, as long as you're drawing it correctly, I don't care which one you go from, right? So I'm going to go how much more is it than 180. And the reason why I'm going to do that is because it gives me my reference angle. But that's fine. So 243 minus 180 is 63 degrees, right? Some people are better at drawing smaller angles, so they like going from 270. It doesn't matter as long as you draw correctly. I do know this, though. I know I have to have a circle in the middle, because that's what I'm rotating about. I know I have to have an initial arm here. My terminating arm is 63 more, so I'm going to guess it's round there. Because it's 90 to get me to the whole thing, right? So I need about 27 this way. And I draw myself a little arrow, and I say 243. Now, quadrant 3, every single time. I am too much of an angle, right? So if I take off this little piece, this is what I don't need, this is what I do need, the little arm, right? I don't need this 180. So if I go 243 and I take off the 180, I'm left with this little angle here, which is 63. So my reference theta reference theta is going to be 243 minus 180. In quadrant 3, I'm always going to take the angle minus 180, and I'm going to get 63. So this here is 63 degrees. My reference theta equals 63 degrees. Quadrant 3, every single time, angle minus 180, right? 337, 0, 90, 180, 270, 360. 337, if I go 360 minus 337, how much do I have? Or how much is 270 more? It's 67 more than 270, right? 67 more, so somewhere in here. So it's going to be like this. 337. Or you can say it's 23 less than 360, right? How do I get my reference angle in quadrant 4? Reference theta. I always want to finish off the whole circle. So I go 360, and I take off the angle, 337, and I'm left with 23 degrees. So this little angle in here is reference theta equals 23 degrees. Okay? Next one, I label. What quadrant is it going to land in? 1, 2, 3, or 4? 2. Because 170 falls between 90 and 180, right? It's 10 less than 180, so it's going to be very close. 170. It's hard to draw my reference angle. So in quadrant 2, my reference angle is always the whole 180, take off the angle. Then what's left over, right? So this whole 180, I take off 170. $180 minus 170, and I get 10. So there's this little angle in here. Okay? We're going to come back to the notes, but we're going to work on a little bit of homework before we move on to the next part, because I need you to know this part really well in order to do well in the next part. So your homework is on page 4 of this notes. If you go to the next page, the bottom, I'll tell you which ones we're going to work on right now, and then we're going to come back. So I'm going to give you about 10 minutes to work on it, then we're going back to our notes. Okay? So it's the page 83 on the 4th page. So we have 1, 2, 3, 4, 1 to 5. So we're going to do numbers 1, 2, and then 3 to 5 AC. You get 10 minutes. And if you work for those 10 minutes, you will be done these. If you need a picture, if you don't have your textbook, you can come take a picture. So the next one, the reason why I wanted you to go through your homework first of those ones is I wanted you to get really good at sketching. And what I did in the last question is I gave you an example and made you of an angle and made you find the reference angle, correct? Now what they'll do is they'll give you the reference angle and the quadrant and ask you to tell them what angle it is. So it's just reverse of what we just did. Now if you remember, the reference angle is from the terminal arm to the what every time? Terminal arm to the x-axis every single time. It makes a bow tie. Bow tie angles, correct? Not hourglass, bow tie, bow tie, bow tie. Okay. So this says determine the measure of the rotation. You did pretty good. Determine the measure of the rotation angle given the reference angle and the quadrant. So we get to sketch it first. Okay? When we sketch, we're going to draw our lines. And then we're going to label. So we have 0, 90, 180, 270, 360. And I want a reference angle. So what was the reference angle from the terminal arm to the x-axis in quadrant 2? So I'm basically drawing the top left of the bow tie. Okay? So I know I'm going to draw my terminal arm. I have to put 0, 0. It's going to be 25 from the x-axis because we're always from the x-axis. So 25 degrees from the x-axis every single time. So I go to the x-axis and I draw myself 25 degrees. So that's not very far. It's here, right? And then I put my terminal arm, which is supposed to be straight, and it's kind of curvy. And then I draw my initial. And I know that this is 25 degrees. Guys, how can I find out what this is? Because this is what I need. Yes. So the whole way across is 180. If I take the little 25 off, I know how much is left. So what's 180 minus 25? 155. The angle at center position, how did I find it? I'm going to go theta equals 180 degrees minus 25. And I get 155. So do you see how the reference angle can be used to get the center position angle? Okay, we'll look at the next one. The next one says 60 degrees. It says reference angle. So I immediately say from the x-axis because it's going to be from the x-axis every single time. I'm going to go draw my little Cartesian plane. Label it every single time. So I'm going to go 0, 90, 180. I can tell you the people who label their Cartesian planes do better than the people who do not. Across the board. First off, they're correct. Second off, it's easier to do when you can see numbers. So, we're in quadrant 4, which is the bottom right. We agree? And I need 60 degrees from the x-axis. So I basically need the bottom right of the bow tie. Correct? So 60 degrees is past half. So it's going to be like here. And then I have the bottom half of my bow tie. Correct? Technically. So this little angle in here is 60 degrees. If you want to draw the part of the bow tie to help you out, go for it. Bottom part of the bow tie, the other part of the bow tie, top part of the bow tie, top part of the bow tie. Right? So this angle from this x-axis to this arm is about 60 degrees. There should be about 30 left from here to here. Does it look like it? Yeah. So you can draw it with the triangle or you can just draw it as the angle and go, okay, takes me 60 to get to here. So that's my reference angle. Now I need the actual angle. So I start here, I rotate about 0, 0, I end here, and I have to put an arrow. Boom, 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 boom. How, with it drawn like that, could I get my center position? What would I do? I go 360 minus the 60, and then I'm left with 300. And I label it. Okay, look what's here. 2 more. What do you think I'm going to ask you to do? Do them. Go. The last one should be stupid easy because the reference angle in quadrant 1 and the angle in quadrant 1 are always the same. So that one should be easy. Let's look at this one. So we draw our Cartesian plane. We label it. Zero, 90, 180, 270, 360. And then I'm drawing 8 degrees. Oh, that's going to be pretty small. 8 degrees to the x-axis. It's even more than 8, but I can't really draw 8. 8's almost unfit. So this is 8 degrees. Then we rotate here. So how am I going to get this angle? 180 plus, this was the easiest one, because you literally just go 90, 180, plus 8 more, right? Like you're literally counting it as you go along. So theta equals 180 degrees plus 8 degrees, which is 188. Then here's, in quadrant 1, oh boy, 0, 90, 180, 270. Yeah, the quadrant matters.
I'll just put 4.
No. 39 is close to 45, so it's almost up the middle.
It's right now.
So it'll be here. And that's on the center. My board, I need to reset my board. But anyways, this is 39 degrees, which is my reference angle, which is also my theta. Quadrant 1 and the reference angle are the same. Okay? So I'm going to add to your homework. I didn't even speak. Yeah, the stuff I assigned was homework. This is the rest of the homework. So 1, 2, 3, 4, 5, 6, and 7. So 6 and 7 are the add-ons.
I like that.